thanks everyone for coming to this talk. I know there were lots of other talks at this time, and so this is a nice revealed preference, and I hope to live up to it. So today I'll be talking about the economics for the Coasean singularity. I'll tell you a little bit about what that concept is, and some interesting research that I've been participating in over the past year or so. It's a broad set of topics, and I'll try to get through it quickly, and I'm really curious what you all think are the most interesting aspects of this work, and to brainstorm like new mechanisms for AI agents. So I don't want to be like lecturing the entire time. And also feel free to interrupt me while I'm talking with any questions, because as an economist, when no one asks me questions, I get very worried. All right, cool. And lastly, I'll mention that I have a lot of wonderful co-authors on some of this work, and also that Amazon I'm not speaking on their behalf in any way. Great. All right, so at this conference, this is not at all a very unusual idea, but we're going to seriously consider that AI agents are going to participate in the economy like human agents. So they're going to make market transactions, they're going to negotiate with each other, and so on. So if we start with that presumption, we are going to then go all the way to the limit to something called the Coasean singularity. This is a straw man. So the Coasean singularity is an idea that we actually didn't define in our paper, so I will define it over here. So what is it? It's that AI agents are going to cause transaction costs to go to zero, resulting in a capitalist utopia and the dissolution of firms, resulting in arrow de Brue markets, which are, the economics, it's like the idealized world in economics. And in fact, in such a world, prediction markets would be a very big part of it, because it posits that there will be state contingent contracts on everything. And why is it going to result in the dissolution of firms? Well, Ronald Coase is a great economist, wrote this paper, The Nature of the Firm, where he suggests that the reason, so the statement that is made is firms are islands of dictatorship in the middle of markets, right? So why do they exist in the first place? And he posited that they exist because it would be too costly for people to use the market for everything. Sometimes it's easier to just have a friendly relation with your coworkers, where you ask them to do something and they'll actually do it without having to do all the contracting, without soliciting the best bid for a given task, and so on. So that might be more efficient if it's really costly to go out and find contractual partners and find the price. Okay, so those are kind of some just high-level ideal. Okay, so some statements about AI agents in the economy. They're going to participate as laborers doing productive work. They're already there. They're going to act as personal agents engaging in the market on our behalf. They're going to collaborate, coordinate, and compete with each other in a variety of ways, just like humans do. And I think just want to stay on this for a second. The way that I envision this is not that we're going to have one God agent, like the Fable 100, that just does everything without interacting with any other agents, and then super plans the entire economy for us in one shot. I think I have a very hard time imagining a world where lots of us don't have our own agents that are interacting with each other. And so Coase's insights are going to hold, and so transaction costs, they're still probably going to exist. They're going to dictate the organizational structure. For both humans, they're going to change how human firms work, but also agents. So we'll talk a little bit about scaffoldings. How should we think about different agents working together? Is it one agent telling others what to do? Are they going to be using other mechanisms? And that naturally leads us to the final point, which is that we're going to need rules and tools and market design innovations to make this new world work. And I feel like this has been very under-theorized so far. Okay. So quick roadmap for the rest of the talk. We'll discuss existing scaffoldings a little bit. We're going to describe market-based scaffoldings and why they might be appealing. I'll tell you a little bit about some experiments with market-based scaffoldings I've done with Rohit Krishnan. And then I'll conclude with some thoughts on market design for these markets. All right. So what is a scaffolding? A scaffolding is a software architecture around a model, right? We've all presumably used Claude Code. It's gonna determine what happens next based on the context and the rules that it is given for specific tools and sub-processes. And it's very natural to think of it as an organizational structure where you have like one head agent that might be the CEO of the scaffolding. It has access to sub-agents, and it's gonna somehow figure out when to call them and when not to call them. And it allows us to, as we well know, to do very, very complicated, long-running things in a way that it just like one model, one set of contexts would not be able to do. Several of my co-authors have a paper, a theoretical paper, talking about the role of tasks and chaining tasks together as a way to generate efficiencies. So you're going to get a lot of efficiencies if this sort of scaffolding is able to do many tasks in a row without having to have a human in the loop do them. So we want to design scaffoldings for that world. Okay, so how does the scaffolding work in Claude Code? And this might be Claude Code like a couple months ago rather than today. So there are markdown files that are going to specify persistent memory and usage patterns. There's going to be a main instance that's going to spawn sub-agents in order to protect its context window, in order to parallelize various tasks, in order to isolate specific risky tasks, and in order maybe to even have some specialization if we think that certain agents are better than others at doing certain things. And very often we might think that sub-agents are going to use a cheaper, faster model such as Haiku instead of using Opus or Fable. And as far as I understand, Claude Code typically has a depth of 1 for these tasks. So it's not having its sub-agents generate additional sub-agents typically. But that's something that's a very natural thing to consider if we think about firms. They have many levels in the org chart. Yeah, so Codex, I think, allows for this more hierarchical structure. It can go down further. I don't know how often it's practically used, but that's an interesting thing to study. There are also explicit roles in a team-based collaboration of agents that Codex has as a feature. OpenClaw is a different sort of scaffolding. Multiple isolated and persistent agents run in parallel. OpenClaw is a lot more focused on being cost-aware using various rules. And I think of all of these, OpenClaw is the one that was from the beginning designed to be using models from various creators. And we might think that that's really important to the extent that different models have different comparative advantages. So we're going to want to use some in certain cases and others in other cases. Okay, so we have a lot of parallels to economic concepts from economic theory. So the finite context window, that's going to approximate limited attention. Communication with other agents or with a person is going to fill that limited context window, and it must be economized. And the compaction of that context is lossy, and so you can't really pay attention to every little thing in that context. Task decomposition, so let's say you need to do something complicated, like create a compiler. You're going to probably come up with a plan with decomposing various tasks. Those tasks are going to be assigned to different models, to different agents. That's like the division of labor in economics. And so it's very natural to think that all the tools related to these problems that aren't designed for AI are quite applicable, including operations research, mechanism design, and industrial organization. So I think like there's a ton of low-hanging fruit. We're just scratching the surface of it. So if you're interested in this, I'd love to chat, but you should also go out and do this work. Okay, so why is a market-based scaffolding appealing? So let me tell you a little bit about that. So far we've mentioned Coase, but now we get to mention Hayek, classic economists. So Hayek has this really awesome paper about the use of knowledge in society. It's an argument for decentralization in markets. Should be no surprise to people at this conference. So people, potentially agents, have distributed knowledge about capabilities. So what can you do? What sort of tasks are you trained to do? Are you capable of doing? what are your preferences? Do you like doing this task? Do you like doing other tasks? And then your constraints. So like in particular, time is a constraint, but also you have other constraints as well. And so if you think that there is this distributed knowledge about these things, that's going to naturally favor decentralized mechanisms, because the very word distributed means that it's not like one central entity knows everyone's capabilities, preferences, and constraints. Okay? And then prices are going to arise as an efficient way of coordinating this distributed activity, just like in prediction markets. Okay, so let's think about a market for contract labor. You can think of something like Upwork. So you post a job. Let's say I need a podcast editor. I'm going to post a job for that. I'm going to get bids on those jobs. When workers bid on those jobs, they have some information about their costs and their ability to complete the task. Not perfect information, by the way, but some information. When they make mistakes, that's going to result in cost overruns, loss to reputation, or removal from the platform. So there is a disciplining mechanism by which workers who are bidding in ways that are inefficient get selected out of the market in the longer run, right? Okay, so that's for human workers. So what about agent workers? So what is an agent anyway? I think this is a word that is very loosely thrown around. Obviously, different circumstances require different definitions. So one very reductionist definition of agent is it's a for loop. I like to think of it as a combination of a model or a set of models that it has access to, a compute environment, a budget, a context, and an owner, which, at least for now, I'm going to say is a human owner, although maybe one day they will have their own rights. So what I'm arguing against is that an agent is just one instance of a particular model doing something that's too thin, and in fact it kind of doesn't really allow for very much specialization, for example, because you might be specialized depending on your compute environment or on your context that your owners have given you that's different from the context that other owners have given. So you can think about competition between scaffolds, for example, is much more natural to think about when you define an agent this way than this way. Okay, so what is the market analogy for AI agents? What are their costs? Number of tokens that are used in completing the task? What is success? Does the agent succeed in completing the task? Do the agents have private information? Perhaps if they have context. The other way in which they have private information is clearly they've been trained on a lot of data. Some of it might pertain to the task at hand. And some models might be able to introspect about that, about their particular knowledge or capabilities with regards to a particular thing. As I'll show you later, it's not clear whether they have access to that introspection yet, but maybe one day they will. Reputation, that doesn't exist for each unique instance. So I really think that when we have, if we were to think about a reputation mechanism for agents, it has to be something that sticks with the owner of the agent in a particular bundle, rather than with like a one-off instance call of an LLM. If we don't have that, we can rely on benchmarks, which are another way of to think about reputation. And then preferences, it's very unclear, right? Like, it does seem that different models like different things. So maybe just like humans, they have preferences. So for example, Andy Hall and co-authors have shown that you can get agents to have Marxist preferences if you work them on really boring tasks. So that's kind of interesting. I don't know whether that's like an epiphenomenon or whether we'll have that even in the future with more sophisticated agents. The other thing I wanted to mention is like production functions for agents. So an agent has many ways of doing something, and usually it does it in a particular way, and we might direct it to do it in some other way. But in principle, it would be nice if we had the entire menu, or if the agent knew the entire menu. Like if it could choose among bundles of the probability that you actually succeed in doing the task and the number of tokens used. So for example, you might use a lot of tokens and almost certainly succeed, or use a few tokens and not. And so we'd want agents ultimately to be able to optimally pick that point in the production possibilities frontier. And this becomes like a pretty complicated task, especially when there are various tools that might be available to the agents. And so far, I don't think anyone has really systematically studied this, but I think it's quite interesting. Okay, so now let me tell you about some experiments with market-based scaffolding. Okay, so if we're going to use markets to coordinate agents, and if we think that's going to work well, like imagine agents bidding, we're going to need these agents to know something about their costs and their probabilities of success. We're going to need these agents to pick appropriate production plans, and then we're going to need them to respond to price signals. So we tried to implement something like this with the set of tasks in SWE-bench Lite. So these are tasks where it's a programming task where there's a patch and it's evaluated by a number of tests. It's pretty standard. It's not the perfect benchmark to use, but we're budget constrained ourselves, and so this is the one we could do in the short run. So what we find is that models are poorly calibrated. Over here we see the mean probability of success that they've estimated. Here we see the actual pass rate, and we see that they're oftentimes quite wrong. For example, Gemini 3 is over-optimistic on its probability of success. GPT 5.2 Pro is under-optimistic on its probability of success. And then in addition to just like knowing whether it can do the thing or not, the estimated tokens that it thinks it's going to use are substantially lower than the actual realized tokens that were used in order to fulfill the task. So far, it doesn't seem like it has that much signal about whether it can actually do something and how much it will cost. So one of the key reasons for markets is not evident in this existing set of models. Nonetheless, we did try to run the actual auction where each of the models bid. The way we instantiated it is that there was an auction, there was a random reserve price that is not known to the agent. The agent is going to bid to complete the task using an expected value calculation based on its own estimated token cost and probability of success. And if the agent wins the auction but fails to complete the task, it loses both the auction and the dollar amount that it bid. And then if the agent wins the auction and completes the task, it gets the dollar amount minus the cost. So we ran this auction process separately for each model first. We see that like the key thing to look at here is the realized profit, so what happened when it participated in these auctions. And this is the oracle profit. So we could also calculate if it perfectly knew its cost and probability of success, how well it would do in these auctions. And we see that there's a pretty large gap between the realized profit and the oracle profit. So these models are very far away from efficiently allocating themselves to these tasks. Yes?
Gemini 3 Pro preview was really bad on the last slide, but now its realized profit is very close to the oracle profit. Do you have thoughts on that?
So the other models are just not winning enough, but this one is over-optimistic, so it's winning a lot. And sometimes it's still not succeeding, but for most of the tasks, it can do them, and so that's why it's pretty close. But I would say it's an artifact of this particular subset of tasks. I should mention, like, this is such a small set of all the tasks we want LLMs to do that I wouldn't necessarily expect the orderings to be the same across all of those. Yes?
We know that it got better even in the context of this experiment if we ran series with the same models. Does it get better about calibration and its own kind of strength and weakness over time?
We can improve it by giving it some more stuff in the context, although it's still not perfect in that world. But I think in our little experiments, if we just had it participate in multiple, it doesn't get that much better. And I think the way to think about it is like how much does it learn from one particular task about another task? It depends. If the tasks are literally the same thing, probably a lot. But if they're substantially different, maybe not as much. Yeah. Okay. Now, what is a market-based scaffolding? Now, instead of evaluating all these one by one in an auction, we have one auction where all the models bid. And then we're going to have a scoring rule by which we're going to select which model we pick based on their bid. And if a model fails, we'll go to the next highest score model. So some early results. So the market, so our scaffold completed 29 out of 50. If you just ran solo GPT 5.2, it gets 24 out of 50. So there's a 5 task difference here. Now, interestingly, with the external scaffold for GPT 5.2, this is, I think this is a codex variation. It does a lot better. This goes to show like why you need to evaluate the scaffold plus the model in conjunction and not just the model by itself. And then the oracle, since we know the ground truth of what tasks the models can do, the oracle would accomplish 42 out of 50 of these tasks. So I guess the so what slide of these exercises is that this is just an illustration. The design space here of these scaffoldings is very vast and interacts with the model knowledge. How do we think about how these models should be bidding? What does it mean for these models to have a reputation? How do we evaluate whether they're trustworthy bidders or not? And I think a very natural idea is to combine this market-based mechanism with also an external router, something like similar to how ad bidding systems work. Okay. Last part of the talk. Market design and some concluding thoughts. Building good agents is going to become a key topic. It already is. And I think there are various aspects of this problem. One is just learning the preferences of the principal, which was us. So how does the agent learn about what products I like or how I like things done versus another agent? Secondly, learning what the agent can do on its own versus what it needs to ask the human for, right? So this is something that we, dangerously skip permissions is kind of maybe not the right way to do things. But it will be good to measure like how often they make type 1 and type 2 errors in terms of asking the human or not. 3, making them rational is pretty important. Here I'm talking about no money pumps. So if they're not rational, you can trick them and take their money. And we see in experiments like Vending Bench where that's actually very easy to do. So they're very far away from just being let loose raw into a market. And then lastly, making them resistant to manipulation. So if we do this right, we get to the good place. The good place, we can get improved preference solicitation and lower search costs. That way, all of us are going to get matched to the best options for us, whether that's the best products or the best houses, the best dates, etc. And furthermore, if we have this awesome matching, that's going to improve incentives for firms to give us stuff that we actually like instead of stuff that they can sell to us. It's going to reduce the amount of puffery in advertising. It's also going to enable a lot more bargaining. So in cases where we have a scarcity of options, we're going to need to allocate them across people, and we'll have our agents bargain on our behalf, and that's going to lead to the right product or the right item to be allocated to the right person. And furthermore, we might even think that firms are going to have less scope to trick us and extract rents based on that. So that's a good place. The bad place, rip-off hell. Prices and dispersion may not necessarily go down. Firms might use obfuscation techniques to preserve or increase rents, like they're going to have better agents than us. I'm particularly worried about markets with externalities, where, for example, in the job market, it's now trivial to apply to jobs, and as a result, the normal way of applying to jobs is dead. So you have to find jobs the other way. We need to design around that. And then, of course, we have some zero-sum games in the economy that might lead to a race to the bottom or an arms race from having a better agent. So that's kind of the bad place. So how are we going to get to the good place? With better economic mechanisms. So deferred acceptance at scale is a very interesting idea. So if you know anything about how doctors find their jobs, they have this centralized matching algorithm, but we don't use that anywhere else. Why don't we use that anywhere else? It requires a lot of effort to specify and learn your preferences about so many options. But we might be able to have our agents do that for us, and then we might get these mechanisms used in a lot more places. We're going to need to introduce a lot more costly signaling. So I think about the academic journal system, where I think giving people like some amount of tokens for submissions and then not letting them submit any more than that. That might prevent a lot of slop from being submitted, or alternatively having people pay money to submit so that they don't submit too much slop. We're going to need to think really hard about the owner of the agent. And so we might need proof of humanity and proof of agent ownership in these markets. We're going to need potentially congestion taxes, like Cloudflare's pay per crawl. And we might need government regulations allowing us to bring our own agents so that we don't get taken advantage of by the agents of other companies. So to conclude, market mechanisms are going to be really useful for coordinating AI agents. We might even want to have the AI agents be trained to partake in these markets, like that be an explicit part of the post-training. And then we need to simultaneously think about developing mechanisms to coordinate the agents and prevent bad outcomes. So yeah, thanks for coming to the talk.
Thanks for the talk. Quick question, just from like a broad conceptual overview. Started with the slide about the Coasean singularity, and then your penultimate slide, what seemed to be heading in a list all the way we could reintroduce transaction costs. So,
well, so to be clear, the Coasean singularity isn't ideal, and I don't think it will happen. Okay. Yeah. So, but if we want to even try to approach it, we're gonna need some of these things some of these new mechanisms. Yeah. Yes.
So, I guess as you were walking through the slides, I was trying to think of the kind of analogs to human specialization, right? So, largely Martin's work, because there's a lot of variance in different dimensions. Humans have different types of cognitive skills and different types of knowledge. It seems like at least some of that variance is compressed with models. Maybe you argue there'll be more, specialized models and so on. But it seems like the only place where I could see that there be significant value is the private information. So if you don't have like private information that another agent can't get off the internet, then is that the main variable we would use to predict whether this is the right use case for sort of agents engaging in kind of this motivation transaction with each other?
Yeah, I guess I'd also say that we're going to see a lot more innovation in the scaffolding layer, and then like different companies might have very different scaffoldings with similar underlying models, and they're going to have different capabilities, or at the very least different like cost success trade-off probabilities, and so we might reintroduce comparative advantage in that way as well. Yeah. Yes.
The thing I was thinking this entire time is that model interpretability might be in the point where if you have sophisticated, like if you're able to prepare market scaffold to profit models and get to a point where you can literally get production function. Like we're talking like sigmas and pi's, like writing them out of work. What information do you think we might get from that? And could we be in a spot where model interpretability allows us to get better production functions for machines than for non-machine entities?
Potentially, although I'm not sure whether model interpretability is going to get us there. Let me get to production. I imagine production functions are pretty highly dimensional objects, and so interpretability is all about bringing those dimensions down into a much smaller set. Then I imagine we get an interpretable model, and then we're going to have to somehow make it more complex to think about a specific production problem. So I don't know. I'm just talking, on the spot. Yeah. Yes.
So it seems to me that for the Coasean singularity to happen, we need compute costs to go to near zero. Otherwise, agents are still running on tokens, which still cost things, and so transaction costs still go zero. And so in that world where compute is still constrained, and transaction costs are much lower than our world, but still existing, can you play out for us how AI firms work? Do we expect lots of agents to form, one single entity, i.e. AI firm? Do we expect AI firms to be but tiny, but lots of them existing?
By an AI firm, do you mean a firm that is owned by a human, but all the workers are AIs, or is it?
Well, it's more about the workers being AI. I mean, who owns it, I presume, doesn't matter to the Coasean world.
Yeah. Yeah. I'm not sure. I imagine it'll be a multi-agent system.
Yeah.
but I don't. I guess what in that? Do you mean like how many agents are we talking about? Are we talking about like 10 or a million agents?
Are we expecting much bigger AI agent firms? You know, firms that have like 1 trillion AI agents working together.
Uh-huh.
Or are we expecting quite tiny AI agent firms, 1 or 2 agents form your firm, just based on this Coasean logic?
So I would imagine that the firms would be smaller because it's much easier for agents to go out into the market and procure services than it is for humans. Like imagine like you need to call, like one way to think about it is like an agent could do something itself, or it can call an API for some very tiny marginal cost and get the answer from a verified API. So just call the API. So that's outside of the firm, right? Rather than having to produce it inside the firm. So yeah, I'd imagine they're going to be substantially smaller than human firms in terms of number of agents. Although maybe there's some parallelizable part of it where it might need to spawn. That's the other thing that AI firms could do is they could spawn very temporary employees very easily and then turn them off. And I think human firms have a pretty hard time doing that. Yes.
You touched on it a little bit. Maybe if you could talk a little bit more about the implications of like the potential use of benchmarks for RGL labs, marketplaces forming, mixture of models to compete in the tasks and what costs look like in that world.
Yeah, I mean, I think if the costs end up continuing being high for the frontier models, there's going to be a huge incentive to economize on those costs. And then you're going to have an entire industry, and you're already seeing some of it form with Open Router and other companies where they're figuring out like the best way to combine multiple models to achieve the same thing with either faster, cheaper, or some combination of both. So I imagine that will be a growth industry, yeah. Yes.
I wonder how some of this biggest kind of change you see in marketplaces. So like, my understanding today is that like these big enterprises in the US, they're kind of are kind of doing this where that like say for an RFP process, instead of humans in the RFP, like the agents are actually copying the proposal, looking at past projects, like seeing what the costs were, and like they basically have these huge agency pipelines with these steps. So like and like the way in which that you bid for a process that you just use the correct mechanisms. Like why does it change it in any way? Like I just feel like it's just going to new. This is going to be continued. Everybody's institutional process is going to be for agentic. But I don't see how the market mechanisms change.
Yeah, so the question is how the market mechanisms change. I mean, I'd say that like there's a gigantic literature in the optimal way to design procurement auctions and RFPs. And I imagine with the agents that optimality is going to be very different than for human firms. So that's like one very simple answer. But I think like in terms of underlying, you're going to use these sorts of mechanisms for a lot more things. Right now, it's a really painful way to procure a service, to have an RFP, wait for people to submit a bunch of stuff. Now, you might just have the RFP and you have agents instantly submit to production plans, and then you get it done like the next minute, That's a lot more feasible now than it would have been before, yeah.
Yeah, my question is around the market mechanisms and particularly kind of the balance between verifiability and reputation. So it seems to me that like it's really interesting to conceive of new and interesting market mechanisms for a problem where it's easy to verify that the work was done correctly, but difficult to do the work in the first place. So we can kind of allow that, but not all work will have that character, and there will be some things where, like you mentioned in these examples around like dating, where it's very subjective whether the work is done to satisfaction. And so then the pressure comes back to like reputation. And so my question there is, will this not burden of reputation bring us back to the carriers of reputation in our current world, which is the firm? So in other words, people will use Anthropic's API because of Anthropic's reputation instead of just my random API that I made because I don't have a reputation. Does the question make sense?
Yeah, the question makes sense. I guess if we have an agent that represents our preferences, we can give it some examples, and then it can try to extrapolate from that. So take the example of this deferred acceptance mechanism. So John Horton has some work showing that it's pretty good at this. Now, obviously not perfect, and always with an experience good. This is not just a dating market issue. It's lots of things. You're not going to know until ex post, until you've like been in that transaction for a long time, whether it's actually good. But at least we can hope to, based on your ex ante preferences and expectations, do a good match. So, yeah. Yeah.
If we want to learn, if we don't have an econ PhD and want to learn more about this prior art of market design and mechanism design that was here long over AI, the important insights in the stage, like what should we be reading?
I mean, very pop accessible stuff is Al Roth's book, Who Gets What and Why. But then there's kind of like textbook treatments of mechanism design. But I would just say like talk to Claude about it, and you'll probably learn.
If your theory is that transaction costs will go down, firms will be necessary, agents will push it on enough. Should we be short the S&P? Perhaps it's everyone always kind of right. Economies will go boom with AI, but not necessarily. We shouldn't actually be long the markets because we're all just going to be individual machines.
Yeah, I mean, so the standard reasons why we might have large firms are returns to scale or network effects. I don't think those are going away. So I would be hesitant to short the biggest companies that have those sorts of moats. But
Perhaps
other big companies, yeah. The question is, do they have something that is scarce that no one else, that prevents other people from effectively competing with them? And if they don't, then I expect smaller companies to really intensively compete with them and outcompete them. Yeah. All right. Well, I'm happy to talk offline. Thanks so much for coming to talk.